Can you hear me, students? Good evening. Good evening. Right. Okay. So, good evening for all of you. So, today we have to discuss carbon increasing reactions, number 7. Okay. So, we have to start from that one. So, quickly write on the topic. Carbon increasing reactions. Carbon increasing reactions. Reactions number 7. Reaction of acid halides. Acid halides with primary or secondary amines. Secondary amines. Okay. Actually, we can't take tertiary amines. I'll tell you what is the reason behind that one. In tertiary amine students, we know that there is no hydrogen. Since there is no hydrogen, actually acid halides cannot react with uh, tertiary amines. Now look at the reaction. Okay. So just imagine we have an acid halide like R C double bond O X. Okay. So you know this is the structure, common structure for acid halide. And we are going to add here primary amine. If it is a primary amine, we know that there are 2 hydrogens connected to the nitrogen atom. If it is a secondary amine, we know that 2 alkyl groups are connected. So 1 hydrogen is there. So therefore, let me take here H/R. If it is a primary amine, we can see that there are 2 hydrogens. If it is a secondary amine, we can see that there is an R group. So let me write down here primary O, secondary amine. Okay. It is reacting with acid halide. Acid halide. They are reacting together in order to produce RC double bond O in R dash H/R. Students, can you tell me what is this compound? What is this functional group C double bond O in? Can you tell me what is it? Kaude, please tell me. What is this functional group? C double bond O in. Yes, this is a amide. This is an amide. Amide compound. That means, students, we can tell that acid halides are reacting with primary or secondary amines in order to produce acid amides, right? Acid halides are reacting with primary or secondary amines in order to produce amides, right? So actually what will happen here is a halogen atom in the acid halide is eliminating with the acidic hydrogen, right? We can say that somewhat acidic, right? Amine, when we consider nitrogen atom, it is basic. But when we consider this hydrogen, we have discussed this one, nitrogen hydrogen group is polarized. Nitrogen is the negative atom, hydrogen is the positive atom. So therefore, this hydrogen is somewhat acidic. So that acidic hydrogen can eliminate with the halide atom as a HX. So therefore, we can say that the byproduct of this reaction is HX. Now you should be able to understand that why I haven't taken here a tertiary amine. What is the reason? In a tertiary amine, students, we know that there are no hydrogens. So this kind of a reaction cannot be taken place if there is a tertiary amine, only for primary and secondary amines. Because in primary amines and secondary amines, we can observe at least one hydrogen directly connected to the nitrogen atom. Can you understand? Right? Is everything okay? Can you understand this reaction? Very easy, isn't it? Right. Okay, now let's discuss few examples, and another reaction is added to our reaction list. Okay. So I believe, I hope that you all are practicing these things little by little. No hurry, students, till you have time. Don't be panic about the quantity of the reactions. You just keep on practicing. Everything will be fine. Okay. Chlorine is eliminating with hydrogen. Then product is CH3, C double bond O, NH, CH3. So by looking at the C double bond O group, you can decide that whether it is a primary amide or secondary amide. You can tell like that also. You can tell like that. Just imagine we have NH2 groups, right? There are two hydrogens. If there are two hydrogens, we can say that this is a primary amide. Students, what about if we have ammonia? In the case of ammonia, in the case of ammonia only we are obtaining a primary amide. So amides also can be categorized like primary, secondary, tertiary. Under the identification of the organic compound types, I told you that not only amines, amides also can be categorized in that. Primary amides, secondary amides, tertiary amides. So likewise. So therefore, when ammonia is there, right? So not only primary and secondary amines, I can add here ammonia as well. So I didn't mention that one specifically, but let's discuss that one as an example. Okay. So ammonia is also can be reacted with this acid halide. Then it is producing a primary amide if there are two hydrogens. Now you can see that this nitrogen is connected to one alkyl group. In that case, this is a secondary amide. If there are two alkyl groups, we can say that this is a tertiary amide. Can you understand? Very easy. Okay, so shall we discuss that ammonia example also? CH3, C double bond Br, and I'm going to add here ammonia. Yeah, with ammonia also it's possible. And then bromine is eliminating with hydrogen, CH3, C double bond NH2. So can you see that? Primary amide, right? If you want, you can write down this one. This is a primary amide. So this is a secondary amide. So HCl is a byproduct. HBr is a byproduct. Got it? Quickly copy down these things. Very easy. None? Shall I erase this part? I'm going to erase this one. Nah? Quickly write down. Now look at the third one. Nah? Third example. Acid halide with benzene compound. And we are going to add here aniline. Right? Students, can you remember? I taught you under the aromatic compounds actually in the first tutorial of the organic chemistry, the last part. I taught you about this one. This is aniline. NH2 group is connected to the benzene ring. So therefore, this is aniline. Aniline. So what will happen here? Chlorine is eliminating with the hydrogen atom. That is producing this. So that's also a secondary amide. Number 4. In the fourth one, I'm expecting what are the two reagents that you have added. Final product is given like this. CH2, CH3 in this way. So what is it? Okay. So we can say that acid halide should be CH3, C double bond O, Cl, and the amine should be CH3, CH2, NH2. Okay. Number 5. Example number 5. So what are the compounds? Let me consider this is aniline. Butanoyl bromide. Number 5. Example number 6. We can say that CH3, C double bond O Cl, a secondary amine CH3 group N. Okay. So this is considered as methyl propylamine. Okay. Okay, students, that's all about this reaction. Carbon increasing reactions number 7, reactions of acid halides with primary or secondary amines. Right? Please remember that reaction. Please remember that. Let's learn the reaction mechanism of this reaction in the theory class. So shall we move to the first exercise then, including this reaction? Are we done with this? Okay, right. Then let's move to the exercise. So when you are doing that exercise, remember students, please check that whether you can remember the previous reactions you learned. Okay. At the beginning, sometimes you might think that when we started these organic reaction sessions, we are repeating the same thing again and again. Now you can understand how important to write down those reactions, the exercises that we are doing. Because by doing those exercises, again, we can revise all the reactions we learned from the beginning again and again. Okay. So please have a count how many reactions we have discussed so far. Exercise. Let's start from ethene, CH2, CH2 double bond. Ethanol. Ethanol. 2-propanol. 2-chloropropane alkyl halide. Then producing Grignard region. Having a alcohol like this, it's a primary alcohol. Here we have a carboxylic acid. C double bond OH means, so they haven't mentioned the double bond, but you have to understand that if they have given that COOH means, definitely it should be a carboxylic group. Huh? The next one, we are producing acid halide in this way, and added compound and producing amide. I think this is the reaction that we learned just now, right? Please complete that one. Number 1. Number 2, let's start from chlorobenzene. Producing a Grignard region like this. Benzo alcohol. Benzoic acid. Benzoyl chloride. Right. Last week we learned that how to convert a carbonyl group into OH and CN. What is the compound we have to add? Okay. Right. Number 1, I'm going to add here diluted sulfuric, PCC, CH3 MgBr, H3O plus, PCl5, magnesium diether, methanol is added with H3O plus 1 and 2. It's compulsory to put 1 and 2. If not, you will be not given marks. They will reduce your marks. Here we can put acidic KMNO4, acidic dichromate, or acidic CrO3, PCl5O, PCl3. Then the reaction just now we learned, we are adding primary amine, like methylamine, to produce this. Actually, I have done a mistake in this conversion. Let's see how many of you can understand, how many of you can identify that mistake, right? I have done a mistake in this conversion. Let's see how many of you can understand that. Tell me what is the mistake I have done in this conversion. Yes, Pranali, good, very good. Yes, that is the mistake. It should be CH2. Where, Amshi? Where it should be CH2. What is the mistake I have done? Nickel platinum? Yeah, nickel platinum. Only one of you told me the correct answer. Students, can you remember? Even in the theories, I told you this one. In addition reactions of alkenes also, I told you this one. Can we do this conversion by adding diluted sulfuric? By adding diluted sulfuric, can we produce ethanol? I told you that in your resource book, they have clearly mentioned that we can't produce ethanol by adding diluted sulfuric. That's the thing, right? So you have to remember those things. I told you, those are special points. Please go again with the resource book. Whatever I teach you, remember, your reference book should be resource book, especially for inorganic chemistry, organic chemistry, environmental and industrial chemistries. Please follow the resource book. So remember, ethanol cannot be produced by adding diluted sulfuric. It's not possible, right? They have clearly mentioned. For others, okay. For others, we can add diluted sulfuric. So in here, what we have to do then? Here, what we have to do then? Students, I told you that we have to add concentrated sulfuric, then it is producing OSO3H. Can you remember? Then secondly, we have to add H3O plus and heat. That's what we have to do. Okay, keep that in your mind. Right, actually these two are two steps. Okay, so therefore we have to mention 1 and 2. If they have given just one arrow, you have to mention 1 and 2 there. Otherwise in the exam they will give you 2 arrows, because intermediate is there, OSO3H, CH3, CH2, OSO3H, intermediate is there. By adding H plus H2O heat only, this will convert into ethanol. Can you remember? We already discussed this one. Shall we go to the second one quickly? Magnesium dry ether. This is very easy. First of all, we are adding methanol, then H3O plus. Then here, what we are going to do is, we are going to add acidic KMnO4, then PCl5 here. So here we are going to add benzene, anhydrous aluminum trichloride. Okay. So this is actually Fiedel-Crafts. What is it? Acylation, right? Acylation. So what is this reaction? Last week we learned that. So we can convert this carbonyl group into OH and CN by adding HCl. Right. So this is nucleophilic addition reaction. This carbonyl group is carbon-carbon double bond is breaking. Hydrogen is going to an oxygen, and cyanide group is connected to the carbon. And here we are going to add PCl5, then the reaction is balanced. So that's what happened here. Okay. So please remember these things. Very, very important. Okay, quickly complete this one. Let's move to the third one. Third conversion. Dihalide converted into alkyne. Aldehyde. Renal region is added. H3O plus. PCl5, sodium salt of terminal alkyne, Grignard region CH3 MgBr, and here we are adding D2O. Complete the third one. Do the third one and the fourth. Shall we discuss third one? Alcoholic KOH. Hg2 plus H3O plus. Grignard region is added, therefore we can say that ONGBr, here CH2 CH3. PCl5 is added. Then sodium salt is added, therefore CH3 MgBr. Can you remember this reaction? I told you this reaction is very important. This is Grignard region is reacting with acidic terminal hydrogens. So here you can see that this is the terminal acidic hydrogen. That hydrogen is taking the CH3 and MgBr is connecting here. So therefore, since we are adding D2O here, what is the product that we have to use? It's not the methane CH4. The compound that we have to use is that Grignard region, MgBr. So MgBr is reacting with D2O, right? Again, D2O is actually what? Acidic hydrogen. Acidic hydrogen means this is isotope of hydrogen, deuterium, but it's also acidic. Then we can have a product like this, CH2, CH3, in this way. Okay. If you have any doubts, tell me, right? We have alkyl halide and we're adding alcoholic KOH. Then you know what happened. Neither. So chlorine is eliminating with hydrogen. So therefore CH2 double bond CH2. So Br2 is added. Since Br2 is added, we can say that carbon-carbon double bond is breaking. Two bromine atoms are connecting. Magnesium diether is added. This is special, students. This is very special. Now, two halogen atoms are there. We are adding magnesium diether. Then, what are you thinking? What are you expecting here? So, this is actually dimagnesium halide, right? Now, hereafter, everything will repeat two times because we are adding now methanol here, aldehyde. We have MgBr group here and here as well. Okay? Then what are you expecting? What do you expect here? 2 MgBrs are there. 2 MgBr groups are there. What do you think? If I write this compound in this way, check this one. CH2, CH2O MgBr, CH2, CH2O MgBr, right? If you write down this one in upside also, that's correct. But since I don't have enough space, I wrote like this. What happened exactly? As you think, students, now MgBr is repeating. There are 2 MgBrs and we are adding methanol. So don't think that we are adding only one methanol molecule. So we are adding that one as a solution. So therefore, there can be more than one molecule. Definitely, they should be. It should be containing more than one. Then what will happen? Since there are 2 MgBr, so 2 ethanol are connecting to this Grignard region, di-Grignard region. That means dimagnesium here in this way. That's why we have CH2OMgBr here and CH2OMgBr here as well. So this group is permanent. CH2, that is permanent. Got it? Now hereafter you can continue. CH2, CH2OH, CH2, CH2. We are adding acidic KMnO4. Both of them are primary alcohols. So therefore, C double bond OH, CH2, C double bond OH. We are adding PCl5. Then what will happen? CH2, CH2, C double bond OCl. Here also C double bond OCl. That's why I told you, hereafter everything is repeating again 2 times. Now we are adding methylamine, primary amine reacting with acid halide. But remember, this is diacid halide. From the both side of the compound, we have the acid halide group. So therefore, what will happen? From the both side, we can obtain products like this. From this side also, we can say that products. So this is the final product. So raise your hand who got this final product like this. Raise your hand who got the final product like this. Please raise your hand. Okay. Yalani. Good. Very good. Very good. Yes. Quickly complete this one. Done. Let's go for the fifth one. Number 5. We are starting from ethanol. So here we have a flow chart. PCC. PCl5. Acidic KMnO4 is added. So what should be the final product? Let's see. Let's go step by step. First of all, PCC is added for this primary alcohol. Then we know that it's ended up with an aldehyde. Otherwise, it's going for a carboxylic acid. PCl5 is added, so therefore alkyl halide is produced in this way. Acidic KMnO4 is added, therefore now it can go for the carboxylic acid. We are adding magnesium diether to produce Grignard region CH3, CH2, MgCl. That Grignard region is added to this ethanol, and H3O plus is also added. Then we can obtain an alcohol like this. They have increased the number of carbon atoms in this way. Then we have 2-butanol in this way. Okay. PCl5 is added, then it is converted into alkyl halide. Magnesium diether is added to that one to produce a Grignard region, MgCl hydrogen CH2, CH3. Maybe something added to this one, which means it can be a aldehyde keto. Let's see. CH3, C double bond O Cl. Benzene and anhydrous aluminum trichloride. Friedel-Crafts acylation. You know what will happen? One of the hydrogens in the benzene ring eliminate with the chlorine atom in the acid halide. Then benzene ring is connected to that remaining carbonyl group, remaining position. Then we have a ketone like this, right? A phenyl ketone. Now we have a ketone, green art region, H3O plus is added. Finally, we can obtain an alcohol like this. So what should be? Here we have the phenyl group, CH, CH3, CH2. So we have a tertiary alcohol like this. Okay. Sometimes in the examination, you might be given this kind of a flow chart. Then you should be able to complete everything perfectly with the relevant regions. Right? Before we go for the next next reaction, let's do some two conversions are there. Let's do them quickly. First of all, complete this one. Remember, students, when you are addicted to this one, you can't stop doing this one. Okay. Maybe some of you might feel, right? I don't know. But honestly, I addicted to this one when I'm doing the exam. Now, when I look at the paper, first of all, I'm looking for what kind of a conversion that I'm given. So I'm trying to get the answer. I'm challenging to myself that, yeah, I can do this. Right? So when I look at the question, I can say that, yes, I can do that. So that much of confidence is there. Because I admire a lot these organic conversions than the other chemistry lessons. මේකේ පොඩි අමුතු සීන් එකක් තියෙනවා නේ. පොදු දෙයක් තියෙනවා මේකේ. Right, okay. Let's move to the conversion number 6. You have to do this conversion not more than in 6 steps. Now it's a chance to evaluate yourself whether you can remember organic reactions you have learned up to now. So we have a amide. We have an amide like this. So not more than in 6 steps. Not more than in 6 steps. So give it a try quickly. Quickly do this one. Anyone completed the sixth one? Raise your hand. Anyone completed the sixth one? Anyone here? Conversion number 6. Right. Okay. Look at this one. In this way. Okay. There are 6 steps. Quickly do the 7th one, not more than in 5 steps. Quickly do it. Amshi, your method is correct, but you have gone through 7 methods, right? 1, 2, 7 steps are there. 1, 2, 3, 4, 5, 6, 7. Okay, that's the issue. And in the first step, you have to add HBr, yeah. So here we don't have to put any ROR because that's a symmetrical alkene. So the issue is there are 7 steps. Ne? So remember in the examination, if they have given to do that conversion within a particular number of steps, right? You have to definitely go through that number of steps or less than that. Otherwise, don't exceed the number of first steps they have given. Okay, they will cut off your marks. That's the thing. Anyone completed the 7th one? Number 7. Done. Got the answer? Raise your hand who got the answer. Asma, Lashmi, sorry, Asma, Dharanisha. Okay, very good, very good. Okay, then since some of you have got the answer, I will do this one. Okay. Number 7. Number 7, not more than in 5 steps. That means the maximum number of steps are 5. So how about if I do the conversion in this way? Since they have given chlorobenzene, definitely green out should be there. And magnesium diether. Ethanol is added with H3O plus. PCl5. Alcoholic KOH and Br. Students, we can do this conversion within 4 steps also, but I haven't taught you that reaction yet. The next reaction only that we are learning that adding dehydrating agents like consider sulfuric, anhydrous alumina, phosphorus pentoxide. So when we add those kind of dehydrating agents, OH is eliminating with hydrogen. Okay, so therefore we discussed that one under the formation of alkenes, right? Under theories. So therefore, but under the reactions we separated and discussed that one. So the next one only we are going to discuss that one. So therefore, I converted this one into alkyl halide, then alcoholic KOH. So this reaction actually we learn dehydrobromination, and then Br2 is added. Then this compound is 1, 2, 3, 4, 5, 5 steps. If you have followed that method, you can do this conversion within 4 steps. So raise your hand who got the answer correctly. Raise your hand who got the answer correctly. Okay, good, very good. Adding zinc and heat, do we have that kind of a reaction, Amshi? Do we have that kind of a reaction in syllabus? No, right? And in the second step, you have added vinyl halide. Vinyl halides are not stable. They are unstable. CH2 double bond CHCl, that vinyl halide is unstable. So how we can add the unstable compound like that? So therefore that is wrong. Okay. And adding that zinc dust is actually not in our syllabus. That adding zinc dust is, I think we are doing that one for the phenol, not for the chlorobenzene. So that's wrong. Yeah, that's why I told you zinc and heat is actually phenol, right? So we can't do that one for the chlorobenzene. I can remember in some organic reaction books, they have given that phenol adding zinc dust, then converted into benzene. For chlorobenzene, it's not possible. Huh? And remember that vinyl halides are not stable. Right, okay. Then we are done with the seventh conversion as well. So do you have any doubts here? So raise your hand who understood the carbon increase in reaction number 7, right? And the relevant reactions, conversions that we discussed. Are we clear? Do you have any doubts? Good. Then let's go for the next reaction. Special conversion reactions number 9. Special conversion reactions number 9. Dehydration of alcohols. Dehydration of alcohols. Friends, this is very easy. Huh? Just imagine we have an alcohol like this. Right? As dehydrating agents, we are using in your resource book, they have given 2 dehydrating agents. Number 1 is concentrated sulfuric, conc H2SO4. Okay. And the second one is anhydrous alumina, Al2O3. But I'll give you another one. This is not in our syllabus. This is P2O5, phosphorus pentoxide. not in the current syllabus, right? Actually, before 2011, we use this one also P2O5, but now you have to use considerous sulfuric and anhydrous alumina. But in case if you use P2O5, they won't cut off marks, but it depends on the marking scheme. Okay, but better you use considerous sulfuric and anhydrous alumina. So what will happen? Dehydrating agent. What does mean by dehydrating agent? Right? What is the intention? What is the purpose of adding dehydrating agent? What a dehydrating agent can do? What it can do? Remember, dehydrating means what? Water molecule is releasing from the compound. We are removing water from the compounds. That is known as dehydrating. Dehydrating agent means the compound that we have added to the relevant organic compound to remove a water molecule from that. And we have discussed this one, right, in theories. So remember, when we add a dehydrating agent like consider sulfuric, but remember we have to heat this one, right? Not only addition of a dehydrating agent, we have to heat that one. Even when we after adding anhydrous alumina, we have to heat that one. Actually, in all syllabus, they gave the temperature also. When we are doing conversions, we use the temperature. With the considerous sulfuric, we use the temperature as 170 degrees Celsius. And with alumina, we use the temperature as 375 degrees Celsius, right? But in your resource book, now they have given only heat, right? So using this symbol is enough, right? No need to mention the temperature. So what will happen? OH is eliminating with the neighboring carbon atoms hydrogen. Okay. So therefore, what will happen? It's producing this kind of a alkene, right? Alkene. Then remember, students, alcohols are converted. Alcohols are converted into alkenes by adding considerous sulfuric like dehydrating agents. Okay. So after the dehydration of alcohols, what is the product? Alkene. So we learn this reaction under the production of alkenes. This is one of the ways that we can produce alkenes, right? If we have an alcohol, then we add this kind of a dehydrating agent, we can produce the relevant alkene. Please remember this reaction. This reaction is very important in the conversions, right? Quickly write down. Please complete it. Then let's consider a few examples. Right? So let's consider a few examples. Example number 1. We have a secondary alcohol, and I'm going to add here, consider sulfuric and heat. So what will happen? OH is eliminating with the neighboring carbon atoms, hydrogen. So we have two neighboring carbon atoms. So we can choose one of them. Let me choose the left-hand side one. So one hydrogen is eliminated, CH2 double bond, CH, CH3. Number 2. So number 2, 2-butanol. Let me add here anhydrous alumina, Al2O3 and heat. So this alcohol is not like the first one because this is asymmetric alcohol. When we are choosing the neighboring carbon atom, we have to be very careful. Can you remember we learned Zaitsev rule? Zaitsev rule means I told you the poor gets poorer. The poor one get more poorer. So what will happen? When OH is eliminating with one of the hydrogens, we have to choose the neighboring carbon atoms wisely. So that is actually following the Zaitsev rule. Zaitsev rule says that when the hydrogens are eliminating from the neighboring carbon atoms, it always from the carbon atom who is connected to less number of hydrogens, poor number of hydrogens. Now, when you consider left-hand side neighboring carbon atom, there are 3 hydrogen atoms. When you consider right-hand side carbon atom, there are 2 hydrogen atoms. Then according to the Zaitsev rule, hydrogen should be eliminated from the which carbon atom? Left or right? Definitely it should be from right side carbon. And then this hydrogen eliminating with the OH, then the product should be CH3, CH double bond, CH, CH3. Friends, I told you this is the major product, right? Even though that we have rules, we know that always rule breakers are there. Neither. Even though there are rules, what will happen? Rule breakers are there. So when it is unfollowing the Zaitsev rule, right? Some of the compounds are there, they are unfollowing the Zaitsev rule. So when they are unfollowing the Zaitsev rule, what will happen? Hydrogen is eliminating from the carbon atom who is rich with hydrogen, right? So that means we can say that anti-Zaitsev rule. So we don't have something like anti-Zaitsev rule. We have Markovnikov and anti-Markovnikov rule. The rich get richer. In that case, we have anti-Markovnikov rule, but we don't have a theory like anti-Zaitsev. But generally, in general case, we can say that yes, if when it is unfollowing Zaitsev rule and doing the opposite thing means definitely anti-Zaitsev. So therefore, hydrogen is eliminating with the carbon atom who is rich with hydrogen. Then we have the minor product CH2 double bond CH, CH2, CH3. I told you, students, remember, we can use the relevant product in the conversions. If you want minor product, you can use the minor product in the conversion. If you want major product, you can use the major product in the conversion. Okay. So therefore, since both the products are there, you can use the relevant compound to do the conversion in conversions. Okay. Right. Third example, CH3CH, CH3CH2OH. Let me add here CONH2SO4 and so this is the OH, and we know that this is the neighboring carbon atom. This hydrogen is eliminated, and then the product is CH3, CH3, double bond CH2. Number 4, we have a primary alcohol like this CH3, CH2, CH2OH. Adding anhydrous alumina and heat. So OH is eliminating with the neighboring carbon atom, this one, CH3, CH double bond CH2. This. So let me see how many of you can answer for this. What is the product of this reaction? No reaction. Yes, correct. There is no reaction. Why? Because students, we know that this is the carbon atom which is connected to OH group. Then you have to go for the neighboring carbon atom. This is the only neighboring carbon atom for the carbon atom who is connected to OH. So that carbon doesn't contain any hydrogens. So therefore, there cannot be any reaction, any dehydrating reaction in this compound. Okay? So neighboring carbon atom doesn't contain any of the hydrogens. Then how that dehydration can happen? It's not possible. So therefore, no reaction. It's not possible. Look at the sixth one, number 6. This is very interesting. CH3OH. Can you obtain the product for this one? This is something very interesting actually. When my teacher was teaching this one, actually, I also couldn't get the product. What should be this one? Yes, Pranali, very good. It will combine with another CH3OH molecule. Yes, correct. Yes, Asma, correct. It will combine with another CH3OH methanol molecule. That's what happened. So as I told you, when we are using this kind of a solution, it doesn't, now when we write down this molecule, it doesn't mean that we have only one molecule. We have the solution, right? We have so many molecules. So therefore, so why can't we think like this? Just imagine this way: CH3OH is connecting with another CH3OH. There are two molecules combined. Anyhow, the dehydration should take place there. Dehydration should happen. So dehydration means a water molecule should release from the compound. Water molecule should liberate from the compound. Then here we can choose OH group from the methanol. And since I told you that another methanol molecule is connecting to that one, we can release hydrogen. We can remove hydrogen from the other compound. Then we have a product like CH3O CH3 in this way. So what is this? This compound is ether. One of the ways of producing ethers. Remember, students, in our syllabus, in our resource book, they haven't asked or they haven't given anywhere to produce ethers. They haven't given the nomenclature even. They have given simple ether molecules, that's all. But we don't know. Sometimes in the examination, they might ask. Right? So there is a one past paper question actually. All past paper question before 2017. In that question, they have asked about this one. Right? But now in your syllabus, ethers, we are not discussing much about ethers. Right? Anyhow, you can just predict this one. You can just obtain the product from the knowledge that you have gained, like this. Okay, this is the answer. Number 6. Done, eh? Right. Okay. Now, without going for the exercise, directly I'm going to discuss the next reaction. Okay, carbon increase in reaction number 8. Write down. Write down the topic. Carbon increase in reactions. Carbon increase in reactions number 8. Reactions of amines. Reaction of amines with reactions of amines or ammonia with alkyl halides. Alkyl halides. Let's see how this reaction is taking place. Reaction of amines or ammonia with alkyl halides, right? Okay, students, now listen to this one very carefully. This reaction is very interesting, okay? This reaction is very interesting. So let me consider here, first of all, an ammonia molecule, right? That means we have alkyl halide like CH3Cl, and I'm going to add here ammonia NH3. Then what is the product that you obtain? What is the product that you can expect? Hydrogen is eliminating with chlorine atom, and it is producing CH3NH2 in this way, a primary amine. Okay, interesting. Okay, we can produce this kind of primary. But remember, students, when these two compounds react this in this way, what will happen is this reaction will never stop at this stage. Right? This reaction will never stop at this stage. Now that means we have a primary amine in this way. Okay, primary amine. This primary amine again reacting with, as the step number 2, again it is reacting with alkyl halide. Okay, that means this is kind of a chain reaction, right? This is kind of a chain reaction. Can you remember we learned under the theories chlorination of methane? That is a chain reaction, right? Chain initiation step, chain propagation steps, and the chain terminating steps. So likewise, this is also somewhat a chain reaction. Let's see. Let's see how we can stop this one. Actually, if we need the product like this, actually we have to stop here. If we need this kind of a product in the conversion, we have to stop here. But remember, this is actually continuing. The product that we obtain is again reacting with the alkyl halide that we have added. Right? So therefore, let's see first of all what will happen. Then let's find out a solution, how we can stop this one at the first step. So HCl again eliminated. Then what will happen? Then we have CH3, NCH3H. So what is this? So this is a secondary amine. Okay. Again, as the step number 3, what will happen? Again, this is reacting with alkyl halide. Hydrogen is here, NCH3. HCl. Then we have a tertiary amine. Now we are going up to a tertiary amine, right? We are going up to tertiary amine. Then we stop at here. Eh? What do you think? No. Again, actually there is a reaction. So then we have obtained a tertiary amine. How that another reaction can take place here? It's not possible. But remember, students, there is another reaction. There is another reaction. Now look at this one. Are we done with the step number 1? Quickly write out this. Quickly complete this reaction. Now, students, look at the step number 4. Right? Step number 4. So the step number 4 is we have a tertiary amine like this. Okay. Students, you know that nitrogen is containing a lone pair. Okay. So nitrogen is containing a lone pair. Actually, these CH3 groups are electron repulsive groups. They are pushing electrons towards the nitrogen atom. So therefore, nitrogen can easily give the electrons for the others. So this is trimethylamine. So trimethylamine is a good base, right? A base means we have another idea for the base, another definition for a base. Okay, we know that a base means someone can produce OH minus. But do you know that we can define acid and bases in this way? If someone can take lone pairs, it is known as an acid. If someone can give lone pairs, if someone can donate lone pairs, it is a base. Lewis acid, Lewis base, can you remember? In the second unit we learned. Lewis acids are the ones who deficient with electrons, so therefore they are taking up electrons from the compounds, they can give the electrons. Others can give the electrons. So therefore they can take the electrons because of the electron deficiency. If someone is taking lone pairs, we can say that they are Lewis acids. If someone can donate electrons, if someone can give electrons for the others as a lone pair, they are good bases. So here this one is a base. Then what will happen? Since CH3Cl is there again in the medium, this is breaking CH3Cl, chlorine is actually taking up electrons. Chlorine is taking electrons, so therefore the bond is breaking in this way. Then this lone pair, now this is CH3 plus a carbocation. This carbocation, positively charged one, electron deficient group is taken by this nitrogen. Okay. Then we have a compound like this, CH3, N, CH3, CH3, CH3. Nitrogen is positively charged and Cl minus is there. Right. So this is actually what? Nitrogen's positively charged a cation. Can you remember ammonium cation? Nitrogen is connected to 4 hydrogens. Same kind of a thing. What do you think? Same kind of a thing. Remember, students, this kind of a compound is known as, right? This kind of a compound is known as quaternary ammonium salt. Quaternary ammonium salt. Okay. Yes, quaternary ammonium salt. Okay. Quater means actually there are 4 groups are there. We can write down this compound as this as well. Ammonium salt. Actually, the reaction stops at here at the quaternary ammonium salt. That's what happened. The reaction stops at quaternary ammonium salt. So we expected that just by adding ammonia, we can stop the reaction at methylamine, primary amine, right? That's what we expected. But now we have ended up with quaternary ammonium salt like this. Okay. Then students, how we can stop this reaction at the first step? How we can stop the reaction at the first step? Yes, we have a solution for that one. In conversions, you can use that. Right? When you do the past papers, you will meet. Okay. you can stop the reaction. This reaction can be stopped at the first step by adding excess ammonia. Not only this reaction, but also the other reactions we are doing with these kind of alkyl halides, right? Not the alkyl halide, but the excess ammonia and excess amines can be added to stop the reaction at the first step. Otherwise, the reaction will go for the quaternary ammonium salt like this. Do you want to go for the quaternary ammonium salt? Yeah, in the reaction, if the conversion is expecting this kind of a thing, then you can just add alkyl halide and the amino ammonia, then you can go for the quaternary ammonium salt like this. Otherwise, if you want to stop that one at the first step, you have to add the excess ammonia or relevant excess amine in the reaction. That excess term is very important. Okay? So take the red color pen and write down the reaction can be stopped at the step 1 by adding excess ammonia. Okay, all right. So just please raise your hand who understood that reaction. Raise your hand quickly who understood that reaction. Do you have any doubts here? Please let me know any doubts if you have any. Right. Good. Yeah, that's ionic bond. Pranali, that's an ionic bond. Between that ammonium cation and chloride anion, that's an ionic bond. Yes. Shall we discuss a few examples on this? Example number 1. CH3CH2Br ethyl bromide, and we are going to add excess ammonia. When we add excess ammonia, students, then we can stop this reaction at the first step, right? So what will happen? Ammonia is there, NH3. The bromine atom is eliminating with the hydrogen, and NH2 group is connecting to the remaining alkyl group. Then we can have this kind of a primary amine. Second one, we have a secondary alkyl halide, and we are adding excess ammonia. Okay, then no issue. What will happen? Hydrogen is eliminating with the chlorine atom, and NH2 group is coming. So simple as that. So what must we do if we want a secondary or tertiary amine? We can't take secondary or tertiary amine. It's not possible. Maybe there can be methods, but we don't know exactly what are the methods. Honestly, I also don't know that one. Maybe there are some methods, or there may not be methods to obtain the secondary amines or tertiary amines, but we can stop at the first step. Okay. In conversions, they are doing how to stop that one in the first step and get the product. Okay. So you can find out that one, search that one, Google, ChatGPT, Gout, everywhere. Search and find how we can stop that one in the secondary and tertiary. And tell me also. Right. Done. Third example. CH3 CH2Br excess in this way. Would you expect this kind of a reaction? Any product from this reaction? No. Chlorobenzene, I told you that benzene, when it is connected to chlorine atom, remember students, there is a partial double bond. So it's very difficult to break that partial double bond. Because of the partial double bond, that chlorine won't be able to remove from that benzene ring by adding excess ammonia or any compound. So therefore, no reaction. There won't be any reaction. Number 5. Aniline in excess with CH3Cl. Then simple as that. Hydrogen is eliminating. CH3 is coming. Right. Now I want to get the product for this compound. I'm adding excess CH3Cl, not excess ammonia or excess amine. I'm going to add excess CH3Cl. So where we will end up? What do you think? Where will we end up with? We are adding here excess alkyl halide, not excess ammonia, but excess amine. Then definitely we have to go for a quaternary ammonium salt. We have to stop at a quaternary ammonium salt. I told you, in order to stop that one in the first step, we have to add excess ammonia or excess amine. Otherwise, the reaction will go for the quaternary ammonium salt. Quaternary ammonium salt. So the quaternary ammonium salt should be like this CH3CH2. So that alkyl group is coming from the CH3Cl. So therefore, 3 CH3 groups are coming here. Nitrogen is positively charged and Cl minus Cl. Okay, so these 3 CH3 groups came from the alkyl halide. This ethyl group is already was in the nitrogen atom. Try to understand. Number 6. This is what happens if we don't add excess aniline. Last example, number 7. We have a secondary amine. This is in excess. We are adding CH3Br. Then no issue. Bromine and hydrogen is eliminating. CH3 is coming here. It becomes a tertiary amine. There are no reaction where both are excess. Okay, both are excess or both are less. So no. So that is actually coming under the same typical reaction. Okay. Right, okay. Students, are we done with this one? Do you have any doubts here? No. Then let's move to the next conversion. Special conversion reaction number 10. Reaction of alkyl halide with aqueous sodium hydroxide or aqueous potassium hydroxide. Right? This is very easy. Friends, we have alkyl halide Rx, and we are going to add aqueous sodium hydroxide or else aqueous potassium hydroxide. So what are you expecting here? What do you think? This is converted into ROH. That means alkyl halide is converted into alcohol, right? Can you remember we discussed the opposite, reverse? The reverse can be done easily. How? How do you convert ROH into alkyl halide? Just imagine we have ROH and RCl, alkyl halide. What we have to do? We can add their PCl3 or PCl5. That's what we have to do. If it is RBr, we can add their PBr3. Then easily you can convert this one. Now we are learning the opposite. How we can convert alkyl halide into alcohol. For that, we can use aqueous sodium hydroxide or aqueous potassium hydroxide. In your resource book, they have given aqueous sodium hydroxide under the alkyl halide. But remember, in past paper questions, in term test papers, they have given potassium hydroxide aqueous as well. So therefore, both of them are correct. I took both of them, right? Both are correct. That's all. This is very easy. Let me consider a few examples, and then we are done with this one also. Example number 1. Quickly write down. Chlorobenzene, no reaction. Okay, quickly complete this. Complete this quickly. Right. Okay. Now let's go for an exercise quickly. Let's go for an exercise quickly. Obtain all the products, all the possible products of the following reaction. Right. Now, students, look at this one. They haven't specified whether this is aqueous KOH or alcoholic KOH. Can you remember? There are two things. They haven't specified whether this is aqueous KOH or alcoholic KOH. Right? If it is aqueous KOH, we can say that the product that we can obtain, one of the product is OH, CH3H, CH2CH. If it is aqueous KOH, just now we learned. But now look at this one, students. Here, another interesting thing. They're asking all the possible products. If they ask all the possible products here, I'm going to consider the isomerism also. What do you think about what is the specialty of this carbon? What we learned under the theories, what is the specialty of this carbon? Chiral, yes, chiral carbon atom, chiral center. If it is a chiral carbon atom, we know that. So there are two isomers D and L. One molecule is rotating plane polarized light into clockwise direction, and the other one is rotating it to the counterclockwise direction. So therefore, I can write down two products like this. Number two, mirror image of this compound. In this. So these are two products. So let me consider this is D plus, dextrorotatory, levorotatory, L minus, and you can exchange them. We don't know exactly which one is D plus and L minus. So this is the case where when we add aqueous potassium hydroxide. Then what if this is alcoholic KOH? Then we have to obtain product like this. Iodine is eliminating with the neighboring carbon atoms hydrogen who is containing poor number of hydrogen. Say it's a fruit. Then hydrogen should be eliminated with this. Then the product is like this. What do you know about this compound? Just consider the isomerism. What is the specialty of this compound? This is the example molecule we learned to discuss cis and trans structures, geometrical isomerism, diastereomerism, right? We can see that in order to show geometrical isomerism, there are two conditions. One is there should be a carbon-carbon double bond. And the second condition is each double bond carbon atom should contain two different groups. This carbon is connected to two different groups, and these two are different groups. Now, specialty of these diastereomerism compounds are cis and trans structures. I told you that the cis structure is kind of a basing, right? I told you that basing and chair. So this is actually basing. Base among. Parna putoda out base them, right? Kadich putoda out base. So where is the chair shape? Here look like this CH3, CH3, hydrogen, hydrogen. Is the chair, kind of a chair. So that this chair structure is trans, and this is cis. So therefore we have four structures. Okay, is that all? Students, I told you that minor product, there can be a minor product as well. Minor product is obtained when iodine is eliminated with the hydrogen who is rich with hydrogens, carbon who is rich with hydrogens. Then hydrogen is eliminating here. Number 5 should be CH2, double bond CH, CH2, CH2. Do we have any isomer for this one? Any stereoisomers? Diastereomerism? No. The second condition is violated. Left-hand side carbon is connected to two hydrogens, two identical hydrogens. Therefore, it is not showing the geometrical isomerism. Enantiomerism, there is no chiral center. So therefore, this is the only product. So we have 5 products. I considered the isomerism here. If I didn't consider the isomerism, actually we have only 3 products. Okay, keep that in mind. So this is for your knowledge. We can get these kind of questions as well, students. We have to prepare for everything. Right, okay. Quickly complete this one. If you have any doubts, put your doubts in the chat box. Raise your hand who understood this. Raise your hand who understood this. Right, okay, are we done? Second question. Number two. You have to do this conversion by using only the regions I have given as a list. I'm giving you here aqueous potassium hydroxide, magnesium. I'm giving you dry ether, PCC is given, KCN, H3O plus, PCl5. Yeah, this is the list I have given to you. Can you do this conversion? They haven't specified the steps, but you have to use these regions only. You can't use any other things. Okay, this will be very interesting. Sometimes you might use all of them, sometimes you might not. Maybe only a few of them. Quickly give a try. Hmm. Okay, raise your hand who completed this conversion. Quickly raise your hand who completed this conversion. Asma, Dharanisha. Okay, Pranali. What about the others? Anyone else completed this conversion? Sarina, done. Okay, very good. Right. Okay. Now look at this one. We're adding egg plus KOH for this one. Okay, ne? I didn't use any other outside compounds. Everything that they have. Raise your hand who completed this conversion in this way. Please raise your hand. We have to add PCl4, you know. Now, raise your hand who did this conversion in this. Quickly raise your hand. Can you understand this reaction, this conversion? Raise your hand who understood this reaction. Okay, good. That's all. I use the same products but considered green region as and added compound because I forgot about the given list. Yeah, that's the thing. So you have to be very conscious about this given compounds. Okay. Sometimes when you're doing the past papers, you will meet these kind of conversions. So they are giving a list. So you have to use the compounds, only the regions or the compounds that they have given in the list. We can't use any foreign regions, any outside regions. That is the condition. Right, okay. Students, I'll give you some conversions to do that one as a homework before the next class. So please do them. So please copy down these conversions, do them as a homework. Next week, we are going to discuss about very important reaction, aldol condensation. Okay. Not more than in 6 steps. Next one. Not more than in 5 steps. Number 3. Not more than in 6 steps. Not more than in 3 steps. Maximum number of steps are 3. Okay, so then do these 4 reactions as a homework. Okay, right. Students, do you have any doubts? Quickly raise your hand who understood the things that we discussed today. Please raise your hand. Do you have any doubts, anything that you want to ask? Please, you can ask. All clear? Good. Right, okay. Then do this one as a homework. You all can do that. Okay, then let's meet on day after tomorrow in the paper class. Until then, bye bye. Have fun. Good night for all of you. God bless you.